Hi everyone, welcome back. Let's see one of the question on the deadlock. There are 6 resources. Every process requires 2 units of resources. How many maximum processes allowed there such that there will not be any kind of deadlock? Right, so to solve this one, just go with the assumption like if I take there is only one process, this one process requires what? 2 units of the resource, right? Maximum resources are there how many? 6, right? If I remove one process resources, that means you are going to get 4. Next, if I allocate for one more process P2, it is going to require 2 units of resource, so the leftover will be 2. Can I allocate one more process? Yes. Then it will get with 0, right? So there are 3 processes that can work parallelly, right? But here 3 is not the answer. Here they are asking for how many maximum processes are allowed to, there will be no deadlock, right? Which means that, can I do like this? Process P1 will get 2 resources, P2 will get 1, P3 will get 1, P4 will get 1, P5 will get 1. Can I do it or not? Yes. This is another way where you can get the maximum process, right? Before this also you can go with P1 have 2, P2 having 2, P3 having the 1, P4 having the 1. This is one way of writing, right? That can be extended to one more process. This is like this. Now, suppose for example, if I extend it to one more level, P1 1, P2 1, P3 1, P4 1, P5 1, and P6 1. So total how many resources are there? 6. Total resources allocated are 6, right? Now, is it going to be deadlock or no deadlock? It is going to get deadlock, guys, because if you want to complete any one of the process, they require one more resource, right? But all the 6 are allocated, that's why it's going to get deadlock. To make it no deadlock, I have to have 5 processes. So the answer for this one will be 5 processes. The reason is, once the P1 complete task, it will be given to either P2, P3, P4 or P5 and then complete everything, right? So which means that maximum process allocated are 5. Less than or equal to 5 can be allocated. But if specifically asking like maximum, you have to go with the answer 5. So if the question is related to how many maximum process allowed such that, like if I modify it, how many minimum processes are allowed to have deadlock, then the answer will be 6, right? So 6, 7, 8 and so on. Out of all those, the minimum value is 6. So the answer will be the 6. Okay, fine. So for example, let's say the number of resources are 100, guys, and each process requires 3 units of the resources. Then how many number of maximum processes are allowed to avoid the deadlock? Means there is no deadlock. How can you do it? Right? It is a simple one. So the earlier problem is a simple one. So you mentioned something like in the form of some mathematical notation representations. But if you have resources 100, how you will manage it? Right? It's a kind of simple aptitude kind of thing. If I am going to have n process, each process requires pi units of resource r, so that if it is equal to r, then it will avoid deadlock. But here the question is, there has to be avoiding deadlock, means there has to be no deadlock. It has to have maximum number of process. So can you check with the previous video so that you can get the clear idea? So for example, I am assuming that n processes are there, n. Each process I am going to allocate 1 unit less than the actual required. 1 unit less than the actual required, so that I can cover the resources. So which means that n is now 50. If n is 50, what will happen here? The number of processes are 50, then deadlock is going to happen, because P1, P2 and so on, P50 process, each process allocated with 2 units, then what will happen? The value will be 100 value will be 100. Then if one process has to complete, it requires one more unit of resource, but is all are done, right? That's why it is going to get deadlock. So to avoid deadlock, can we reduce the number of process? Yes, number of process by 1. So answer will be 49 for this. Is it okay? Yes. Right. For example, if you want more clarity, I will take one more. R value is 100. Number of resources required for each and every process is 2. Then maximum number of processes to avoid deadlock. What will answer? Simple one. There are n process. Each process requires, I am trying to take it as 1 unit less than the actual required, is equal to 100. So n value is 100. If n value is 100, that will lead to deadlock. To avoid deadlock, I can reduce one process, one resource less than that, so that you don't have any kind of deadlock. Here n equal to 49, there is no deadlock. This way you can able to solve the given questions, guys. These are very important. Hope you understood this kind of problems. Thank you.